at is, would you call that a definition of energy or something like that?
A signature.
A signature, okay, from each frame, and then we'll combine it all and get more of a understanding. This is just the process. This is the process. Okay. Okay, so all the data is now all calculated on the computer. Krishna, what should we do?
Well, first we have some tea.
Okay. So sample one is
sample
red.
1 to 3
1, 2, 3.
are baseline.
Hold on. So these colors are baseline. Okay.
Yes.
All right.
Then 4, 5, and 6
Yeah.
are the coal house. This bottom illustrates that by a statistical distribution called ANOVA test, they are statistically dissimilar. So when we look at the first three, which was the baseline water, and this is area. Area references the number of pixels as the droplet around each frame.
All right.
So what we are looking at here is 1, 2, 3, 150 frames, 150, 150, and this is the mean of all of them. So we can see that that's quite consistent. It's very quite consistent, because the range there is a very narrow range from let's see here. Let's get to.
Well, what's this one over here?
Where is my dear cursor?
Oh.
3393. So it is like 33 values, 3376 to 3393, which was the baseline. Then we have here 1, 2, and 3. This is coal.
Cool. Wow.
So we can see that not only is there a drop in the area, which is then observed from here,
That's
which is fairly big. It's greater than a 10% drop.
Yeah.
So it is observable. And then what we are seeing here is the area, which is the emanation of the droplet, has increased, and it also shows that it's fairly consistent.
Wow.
There. And even this spread, even though this drop, let's see what the value of the variation is in the drop, from 3101 to 3011. So that's well within a 10% range. So this is still within a distribution that establishes that the...
So make a conclusion of that.
Wait. Now let's go to another screen. So here we
all
observe.
right. I want conclusion.
Here we observe. Let's look at all the parameters.
All right. Whoa.
And intensity. Now we know what intensity means. The level of emission, light emission. Here's the baseline water, and we see observe over here is that this emanation, even though it is slightly at a higher value, but actually it isn't quite, because we look at 50, 55, 56 to 57, 59. So that's also within a 10% range. So essentially there isn't that much of a change, but there is a disorganization that we observe here versus organization here, purely because of the spread of these bandwidths.
Wow.
That which means that is more, there is more information that is not fully being exchanged coherently.
It's not coherent.
I would say. Whereas we see here, there is less,
Is it
just
solar?
like it is. Yes.
It's almost symmetrical.
Okay, it is almost symmetrical. So this is our form. So let's go to entropy. It's an important parameter. So here we have entropy. So entropy is a state. Entropy is a state where is chaos, state of chaos. And so here is the baseline. So we can see baseline values traveling from 2.5 to 2.67. And so the water from the house with coal, ranging in parameters from 2.5 to 2.74. And the third part, water inside solar home, ranges from 2.6 to 2.62 to 2.67.
Wow.
So we can see that there is
That's
certainly
That's good.
an observable process and being recorded. So, so here is an observation, and this is a very important observation.
Wow.
Again, referencing entropy in spaces. to which what you had originally sought to observe.
Well, I just keep on loading here.
Yeah, no. So we saw a number of different statistical graphs, and I don't know, I'll just tell you my conclusions as just someone who really should have. It's to me that the baseline, which was in this office, had the ability to almost maintain symmetrics. So it's all its statistics were 1, 2, 3 with the same distance. The Cole House, I didn't see any order to the data, the water that came out of it. So nothing became structured. I would guess it stayed the way it was. And then in the Solar House, which I mean I think this is if this is the only result, that's fine. Is that the energy is the graph was almost equal for all samples, so it had more consistency or harmony amongst each sample at least. Of course, we just started. Okay, that's me. Now what do you think?
Well, you've condensed that. You've nutshelled it. You've condensed, nutshelled it.
But disagree.
The primary data is indicating. It's very clearly indicating that there is observable processes between all the three stations: the baseline water station, the coal house station, water station, and the solar house water station. The essence of all the process clearly illustrated that between the baseline there was a stronger presence towards alignment, coherence. We saw that with the solar water samples.
Yeah.
Just in terms of the dispersion of all the various data charts.
So I have a question though. I'm sorry to interrupt, but I think it's important. So
Okay.
you have the baseline in this room, and this room goes through a lot of, healing and wellness and all sorts of things that go on here. Does that contribute to what we saw as it being more, symmetrical or whatever word you want to use?
Of course, what I would observe from the data that it is clear from this study that we did with quite a vast body of samples we have, that there is definitely a phase shift in content between the coal house and the solar house, and it is quite substantial.
On the one above it all the way to the left, and the one that it's touching, purple, that's the coal. And look at that. Again, it's statistically they're actually equal, and that's the solar part. Okay, what's the next one?
Spatial fractality.
Okay, again, you get this symmetry, which is nice from the baseline. Look at the coal. You got the big one, the little one, and way on the bottom another one. And look at that, man. The solar is right in line.
Yes, yes.
That's harmonic, man.
Yes.